Hello everyone, this is Hymavathi, Assistant Professor in Mathematics, Department of Science and Humanities, MLR Institute of Technology. So in the last session, we discussed about the definition of exact differential equation and method of finding solution of exact differential equation, and we did one problem on exact differential equation. So today in this session, we'll discuss about the definition of non-exact differential equation, integrating factor, and the method 1 is nothing but the inspection method to find the non-exact differential equation solution, and we'll do the problem on non-exact differential equations. So let me see what defines the non-exact differential equation. So given differential equation of the form m dx plus n dy is equal to 0. So here m and n are functions of x and y. When we are saying this differential equation is non-exact, that means if dou m by dou y is not equal to dou n by dou x. So if the condition dou m by dou y is not equal to dou n by dou x exists, then we can say the given equation m dx plus n dy is equal to 0 is a non-exact differential equation. So now let us see one example for non-exact differential equation. So y dx minus x dy is equal to 0. So now we have to verify this differential equation is a non-exact. So what is the conditions we have to find out? So we have to find out dou m by dou y and dou n by dou x values we have to find out. If these two are not equal, then we can say this differential equation is non-exact. So comparing with the actual form of the differential equation, so that is m dx plus n dy is equal to 0. So here m is equal to y and n is equal to minus x. And now we have to do the differentiations. So on m with respect to y differentiation partially. So dou m by dou y value is 1 since the derivative of y is 1. And dou n by dou x. So differentiation on n with respect to x partially. The derivative of x is 1. So before we have the minus is there, so that we will get dou n by dou x value is minus 1. See here, dou m by dou y value is equal to 1 we got, and dou n by dou x is equal to minus 1 we got. So that these two are not equal. So dou m by dou y is not equal to dou n by dou x. So that this differential equation is non-exact differential equation. Then how can we solve the solutions of non-exact differential equations? So first of all, you have to reduce the non-exact differential equations to the exact differential equation with the help of integrating factor. So what defines integrating factor? Now let me see the definition of an integrating factor. So integrating factor defines if a differential equation multiplied by a factor becomes exact, so that factor is known as integrating factor. So let me see again the definition of an integrating factor. If a differential equation multiplied by a factor becomes exact, so that factor is known as integrating factor. So see the example. Take the previous example, y dx minus x dy is equal to 0. So we know that already this differential equation is a non-exact differential equation. Now we are reducing this differential equation to the exact differential equation by using the integrating factor. So what is the factor we have to take? So here you have to take 1 by y square is an integrating factor. So this integrating factor you have to multiply with this differential equation. So by multiplying on both sides, so we will get y dx minus x dy whole divided by y square is equal to 0. Then now split this terms. So y dx by y square minus x dy by y square is equal to 0. Now here the one y was cancelled. So 1 by y dx minus x by y square dy is equal to 0. Now again this is of the form m dx plus n dy is equal to 0. So what is m and n here? So where m is equal to 1 by y and n is equal to minus x by y square. So now see the derivative values on m with respect to y differentiation partially. The derivative of 1 by y square is minus 1 by y square is the derivative. And on n with respect to x differentiation partially, so here minus 1 by y square is a constant since we are doing with respect to x differentiation partially. Now the derivative of x is 1. So this value is minus 1 by y square. So therefore see the derivative values of both. So dou m by dou y value is minus 1 by y square we got, and this value is also equal to dou n by dou x. So now this differential equation is exact differential equation. So now we can decide here this 1 by y square is an integrating factor. So after multiplying this integrating factor to the non-exact differential equation, so this differential equation converts to the exact differential equation. After converting into the exact differential equation, so we can find a general solution of exact differential equation. Then how can we find the general solution of this differential equation? Already we discussed in the last session how can we find the solution of exact differential equation. So we can proceed in that process, then we will get the general solution of non-exact differential equations. So now let me see what is the method 1 of finding an integrating factor. So actually that method is nothing but inspection method. So what's the inspection method actually? So with some experience, integrating factor can be found by inspection. So that we are saying that is an inspection method. So it is necessary to group certain terms in the given equation to make the equation readily integrable. So the following differentials we are using in the inspection method. So see the first differential form is, suppose if the equation of the form y dx plus x dy is there, so that directly we can write that equation into the form of derivative of xy. So then later we can do the integration, we will get the solution of the equation. So now see the second formula. The second formula, suppose if the given equation of the form y dx minus x dy by y square is there, so instead of this we can write directly derivative of xy by x by y. And the third formula is x dy minus y dx by x square. This can also be written as derivative of y by x. And coming to the fourth formula is, so x dy minus y dx by x square plus y square is equal to, so this can be taken as derivative of tan inverse y by x. And the fifth formula is x dy minus y dx divided by xy is equal to, this can be taken as a derivative of log y by x. So here we are using the inspection method. So in the inspection method, so we are using the following differentiation formulas. So now let us see one problem on the inspection method. So see the problem, the solve y dx minus x dy plus 3x square y square e power x cube into dx is equal to 0. So now here we are using the inspection method. Whenever we are using the inspection method, So no need of verifying the given differential equation is exact or non-exact differential equations. So directly we can do the general solution of given differential equations using the inspection method. Then how can we form a grouping? So here we are using the grouping for certain terms. So what are the terms we are taking? Then what is the term we have to multiply or divide on both sides here? So we have the formulas in the inspection method. We can use that formulas. Then we can do the integration and finally we will get the general solution of the given differential equation. So now we have to multiplying 1 by y square. So here we are multiplying with 1 by y square on both sides. So y dx minus x dy plus 3x square y square into e power x cube into dy whole divided by y square is equal to 0. So now we are using the inspection method. So we have to write the given differentiation into the form of a derivative of a function. So before going to form that one, so we have to multiply with one factor, then only it will be converted into the form of derivative of a function. So here I am multiplying with 1 by y square on both sides. So now, so here I am treating x dy plus y dx minus x dy plus 3x square y square e power x cube dx by y square is equal to 0. Then now I am treating y dx minus x dy as a single term. For this term, I am dividing with y square. Y dx minus x dy by y square plus 3x square y square into e power x cube by y square into dx is equal to 0. Right. So from the first term, so we have the formula is there. So which is nothing but this is derivative of x by y. Coming to the second term, so here you can cancel the y square we can cancel. The remaining we have 3x square into e power x cube dx is equal to 0. So the first term is, so we know that already, so derivative of x by y plus the second term is the whole in terms of with respect to x. So this term also can be written as derivative of e power x cube is equal to 0. So then how can we get this term 3x square into e power x cube is nothing but the derivative of x cube. So once see the cross check. So what is the derivative of x cube? So derivative of e power x is e power x, but in the power we have x cube is there, so that we have to write into derivative of x cube. So e power x cube into what is the derivative of x cube? Derivative of x cube is nothing but 3x square. So this is equal to 3x square into e power x cube is the value of derivative of e power x cube. So that instead of 3x square e power x cube into dx, we can write derivative of e power x cube is equal to 0. Now integrating on both sides. Now integrating on both sides, we will get the general solution. So see the integration. Integral derivative of x by y plus integral derivative of e power x cube is equal to c. So we are doing an integration for these derivatives so that the integration and derivatives are the reciprocals, so that these two terms was cancelled. So we will get here x by y is the integration of derivative of x by y. And here the integration of derivative of e power x cube is e power x cube is equal to c. So this is the general solution of the given differential equation y dx minus x dy plus 3x square y square into e power x cube dx is equal to 0. So this is the method of inspection. So what's the method of inspection actually? So just you have to check the given differential equation, use the group a certain terms. That group of a certain terms you have to write into the terms of derivative of a function. Then finally you can integrate, we will get a general solution of a given differential equation. So here no need of verifying whether the given differential equations are exact and non-exact. Directly we can get a general solution of the given differential equations. So this is about the inspection method. So and this is also very simple method, also we can get a general solution. So today in this session, what's the topics we discussed? In this session we discussed about the non-exact differential equation and integrating factor, and the method one is nothing but inspection method. And we did one problem on inspection method. So these are the topics we discussed in this session. So next session we will discuss about the method 2 of finding an integrating factor. So guessing an integrating factor is not always possible in the inspection method. So that we are using the methods to find an integrating factor. So here we have the totally 4 methods are there. So that methods we will discuss in the next session. Thank you.